All right, in problem 7, we have an aircraft that's coming in for a landing. It's on approach at a nice angle of just 2 degrees or so. And we've got the mass of the aircraft. We have its velocity. We know its ground speed. Now that's not the velocity of the airplane. That's its ground speed. So we know its velocity in this direction. It's x velocity, but we don't know its vertical velocity yet. So we've got to figure that out. And this has this assumption in it that the landing gear are the only thing that keep you from, that are involved in slowing you down vertically. Now, there's more to it than that. There's ground effect. As you get closer, you get a little bit more lift and things like that. And if you want to look at a ground effect aircraft that's cool, look up flare craft. Flare craft, invented by a guy that lived by car 2 hours out of New York City. He got tired of a 2-hour commute. He designed a flare craft that he could put out on Long Island Sound and zip into work really quickly. Okay, so we're coming in at 2 degrees. We know our x velocity, but we don't know our y velocity. And it's our y velocity that's going to be here. It's going to be important here because we've got to figure out our y velocity so we can look at momentum in y and do the same thing we did in problem 6, where the force in y is going to give us our change in momentum over a certain amount of time. And we're assuming all of this force comes from the landing gear in this problem. Okay, so we know the ground speed. That's Vx. And we know this angle is 2 degrees. That means that one is 2 degrees. Let me draw this a little bigger. We know that the total velocity is at an angle of 2 degrees because these are parallel lines. If you remember your geometry, these are parallel lines. They're bisected by this line here, so you get 2 degrees here and 2 degrees there. So we know Vx. We need to know Vy so we can get the momentum in the y direction. Well, tangent of this angle, I'm just going to put in theta. Tangent of theta is opposite to the angle is Vy over Vx. So tangent theta is Vy over Vx. We can get Vy very quickly here by solving for Vy. All right, so now we know Vy. Okay, we know Vy, and we want to get to the momentum, and I gave you this hint. Now you have enough information to figure out the vertical momentum, right? So the vertical momentum, Py, is just the mass of the aircraft and passengers times Vy. Now we know the vertical momentum. We know how long it takes because we're given delta t. Delta t is 212 milliseconds. All right, so 0.2 seconds is how long you have between when you first touch and you've settled into the gear. Okay. So what is the average force the plane is going to experience? Well, we're going to go back to our impulse equation, and we're doing F equals delta P delta T. Delta P over delta T. So F, the force, and again, we're looking for the magnitude here because this is negative force. It's opposite to the direction of motion. So it's a negative force. But we're just going to go with the magnitude, which is Py over delta T. And we're going to get how much force it takes to stop the vertical motion of the plane in the amount of time it takes for the plane to settle down into the gear. And there you have it for this problem. Good luck.